So again, another partial fractions example. This time our denominator has a bracket squared. It would still be the same kind of method if we just had x squared and then another bracket. Okay, so our three forms that we wrote down in the first partial fractions video are here. We're now looking at something like this. So this is the sort of form we're using. It doesn't matter which order they come in, okay, but what we notice is that ax plus b is still there, okay, but the cx plus d is written as singular there, so the power of 1, and then squared there, so it's written as two separate fractions. So that's the main thing. It doesn't matter about the order so much, okay, so we're going to write it as an identity. So we've got 11x take 16 all over 2x take 1 squared x plus 3 identity a over so because this comes first, it's just a habit and kind of write it in the first fraction. So I'm going to use just 2x take 1, then I'm going to use the square version, and then I'm going to use the bit that I haven't yet, which is the x plus 3. So our first step is exactly the same as the other two videos. We make the denominators the same over here. So I'm happy with my first fraction. So I've got 11x take 16 all over 2x take 1 all squared, x plus 3, identity. This fraction we need to multiply by another one lot of 2x take 1 and x plus 3. Okay, because I've already got one lot of 2x take 1, but I need a squared version, so I've got to multiply by another 2x take 1. My second fraction, I've got my 2x take 1 all squared, I've got that part, I just need the x plus 3, so b times x plus 3 plus the c, I need to multiply by my squared brackets, so 2x take 1 all squared, and my denominator becomes 2x take 1 all squared brackets x plus 3. So the same second step as the last couple of videos. We've now got the same denominators on both sides, so we're going to just equate the numerators. So you've got 11x take away 16 identity a brackets 2x take 1 brackets x plus 3 plus b brackets x plus 3 plus c brackets 2x take 1 all squared. Okay, so we now need to pick some suitable values to use for x. So if I start with this one, it's not an integer, so I'm going to start with an integer value. So I'm going to use negative 3, because negative 3 plus 3 gives me 0, so that's going to get rid of the a. Negative 3 plus 3 equals 0, so that's going to get rid of my b, so it's going to help me find c first. So when x is equal to negative 3, I end up with 11 times negative 3 take 16 is equal to, a becomes 0, b becomes 0, so it's just my c. So two lots of negative 3 is negative 6, take away 1, it's negative 7 squared. So 11 times negative 3 is negative 33, take away 16 is negative 49, equals negative 7 squared is 49, so I've got 49c, so c must equal negative 1. Okay, so we've managed to find our first value. So now we're going to substitute in, well, we're going to have to substitute in a fraction. So to make this bracket 0, 2x take away 1, then x must be a half. So that will get rid of this section. So that will get rid of my a, that will get rid of my c. So I'll be able to find my value for b. So when x is equal to a half, I've got 11 times a half, take 16, equals, this becomes 0, this becomes 0, so I've just got the b part. A half plus 3 is 3.5, or 7/2. Okay, so then I'm going to work this out, so you can use your calculators. You are entitled to use them in the exam. So 11 times a half, take away 16, is -21/2 equals 7/2b. So that means that b is equal to -3. Okay, so we found a value for b. Need to move that up a bit. So we found a value for b and we found a value for c, but now there aren't any kind of obvious values I can use for x to find a. So what I'm going to do is I'm just going to substitute in x equals 0, because that's quite an easy number to substitute in. So when x equals 0, okay, so we know 11 times 0 is 0, take away 16 is -16. 2 times 0 is 0, take away 1. Take away 1 is -1. 0 plus 3 is 3. Add, well, I know that b is -3. 0 plus 3 is 3. Add, well, c is -1. 2 lots of 0 is 0, take away 1 is -1 squared. Okay, so you can now start to work this out. So -16 equals -1 times 3, so I've got -3a. -3 times 3 is -9. -1 squared is 1. 1 times -1 is -1. Okay, so I've got -16 equals -3a, take away 10. I'm going to add 10 to both sides, so -6 equals -3a. So I know that a is equal to 2. I can divide both sides by -3. So I've now got values for a, b and c. So all I need to do is just write it out properly. So I've got 11x, take away 16 equals, identity, 2x, take 1 squared, x plus 3. So over here, my a is 2 over 2x, take 1, plus my b is a -3, so -3 over 2x, take 1 all squared, and my c is -1, so take 1 over x plus 3. So you've written it in the formal way, don't need a plus and a negative sign here. Okay, it's exactly the same principle if you had, say if we had 11x take 16 over x squared, brackets x plus 3, then we would have a over x plus b over x squared plus c over x plus 3. Because I've got that squared term, I use it individually and I use the squared version on a separate fraction, and then obviously my third bracket is my x plus 3.